the previous video, we looked at how to name ionic compounds, and we said that ionic compounds were those compounds that were composed of a metal combined with a nonmetal. In this video, we're going to look at how we name molecular compounds. And molecular compounds were typically those that were composed of two nonmetals or more. Okay, so if we look at a compound and we see that it has a nonmetal, so something from the right side of the periodic table, bound to another nonmetal, then we're going to count that as being a molecular compound. Okay, and there's some similarities with how we deal with molecular compounds to what we saw with ionic compounds, but there are also some key differences. The biggest difference is that we're not going to be dealing with charges. Okay, since we're dealing with nonmetals bound to nonmetals, we don't have a clear cation or anion. Not only that, molecular compounds are a little bit strange. For example, I could have a compound composed of nitrogen and oxygen where the ratio of the two atoms is 1:1. But I could also have two nitrogens for every oxygen. Or I could have one nitrogen for every two oxygens. Or I could have two nitrogens for every 5 oxygens. Okay, and there's other examples as well. And if I were to name each one of these using the same convention that we use for ionic compounds, they would all have the same name. They would all be nitrogen oxide. And we can't have the same name for multiple compounds. So the way that we're going to name these things is by, starting off with the same thing that we did for the ionic compounds. So let's look at this case right here first. Okay, we know that we have nitrogen. Okay, and even though there's no cations or anions, the element that's listed first, okay, is going to be the one that we list first in the name. So we have nitrogen. So just like with the ionic compounds, that first named element is just the name of the element. And then we have oxide. Okay, now we have to indicate how many nitrogens are there and how many oxygens are there, since it's no longer something that you could determine on your own. So we use prefixes. And to show that we have two nitrogens, we put the prefix di in front of nitrogen. And to show that we have 5 oxygens, we put the prefix pent in front of the oxide. So this becomes dinitrogen pentoxide. Now if we look at N2O, this would be dinitrogen monoxide. Okay, so the prefixes that we deal with are going to be, for 1, mono. For 2 is going to be di. 3 is tri. 4 is tetra. 5 is penta. And the rest of these are pretty straightforward. They're just based on geometric shapes. So we get 6 is hexa. 7 is hepta. 8 is octa. 9 is nona. And then 10 is deca. And that's all you're responsible for, is knowing 1 through 10. But there are prefixes that go all the way up into the 20s and 30s and all that. Okay, now there's one other rule that we need to bring up here. And that is that if we have a compound where the first element only has one atom, we never start the name with mono. Okay, it's just a convention that we follow. So instead, we just leave the prefix out. So for the first example, the NO, Okay, we might want to call this mononitrogen monoxide or monoxide, but because of this rule that I just shared with you, we can't. We call this nitrogen monoxide. Okay, so we use the mono prefix for the oxide, but not for the nitrogen. And we see the same thing for NO2, where we have just one nitrogen, but we just start off with the word nitrogen, not mononitrogen, and that's dioxide. Okay, and this is very similar to what we see with some of the carbon compounds like CO and CO2. Certainly compounds that you have encountered before, and you have heard people say carbon monoxide, not monocarbon monoxide. And carbon dioxide, not monocarbon dioxide. Okay? So that's an important rule to remember. We never start with the prefix mono. Okay, one other thing that we need to look at is how we deal with these prefixes depending upon what element we're working with. In other words, what I'm saying here is I said that the prefix for one is mono, and we know that the name for an oxygen anion would be oxide. Okay, and it raises the question of, well, how do we put those together? Okay, it's not going to be monoxide. Okay, so we have to get rid of one of those O's. The same thing goes for things like penta. So penta plus oxide, you might expect it to be pentaoxide, but it's not. Okay, we get rid of that A. So it's just pentoxide. Okay, so this is a general trend, because if, let's say that this was not an oxide, let's say it was a sulfide. Okay, so if we have a mono combined with sulfide, that would be monosulfide. Okay, or if I had 5 sulfurs, it would be a penta plus a sulfide, and when we bring those together, that's a pentasulfide. Okay, so what's the difference between the two? Well, the difference is whether or not the element's name starts with a vowel. Because if it starts with a vowel, you wind up with 2 vowels together. Okay, generally speaking, we're going to avoid that. Okay, so if it looks like you're going to be putting 2 vowels together, get rid of the vowel that's on the prefix. Okay, so right here I crossed out that O, but I really meant to cross out this O. Okay, because that's what we're going to be knocking off. Okay, so that's just something to keep in mind when we're dealing with these molecular compounds. Now, there are other molecular compounds that we encounter frequently that we could classify as being acids. Actually, I should say the acids are based on molecular compounds. So let's take a look at the hydrogen halides. Okay, so what I'm talking about here are HF, HCl, HBr, and HI. Okay, now, assuming that these are all in their natural state, so for HF, that's going to be a gas. Hold on. HCl is going to be a gas. HBr is going to be a liquid, as is H. Actually, no, these are all going to be gases. Okay. The names of these, okay, are going to be based on what I just showed you, except we don't have to use any prefixes because they're all in a 1-to-1 ratio. So we have hydrogen fluoride. Okay, and pay careful attention here. Notice that fluoride's spelled UO, not OU. So it's fluoride, not fluoride. Okay, then we have hydrogen chloride. And we have hydrogen bromide. And hydrogen iodide. Okay, but if any of these were dissolved in water, so we can put a little AQ after each one of these to show that they've been dissolved in water, and we'll talk more about that in Chapter 4. Okay, if they're in water, the name changes. Okay, so HF, instead of being called hydrogen fluoride, is called hydrofluoric acid. Okay, and HCl would be hydrochloric acid. HBr would be hydrobromic acid. And then HI would be hydroiodic acid. All right. Okay, there are some other compounds that contain hydrogen as well that would qualify as being molecular compounds. And that would be things like CH4, or BH3, NH3, OH2, which is the same as H2O, and then SiH4 and PH3 and SH2. Okay, these have more or less common names that you just kind of got to know them. So CH4 is methane, and that's an organic compound, so that's part of the organic naming system. BH3 is known as borane. NH3 is ammonia, not to be confused with ammonium, which is NH4+, and this is a polyatomic ion. In fact, it's the only positively charged polyatomic ion that we work with in this class. Okay, of course, H2O is water. SiH4 is silane. PH3 is phosphine. And then the H2S or SH2 is hydrogen sulfide. Okay. Now, we're going to turn our attention to some more complicated compounds, but that's going to be in the next video. But this is how you deal with most of the molecular compounds.